To determine the coordinates of the points where the graph is crossing the x-axis or the x-intercepts of a function, we equate the equation to 0 and solve for x. So generally, when determining the x and y intercepts, to find the x-intercepts, y is 0. To find the y-intercept, we substitute x with 0. In this case, we are calculating the coordinates of A, B, and D. Those points are the x-intercepts of the functions. A and B are the x-intercepts of the parabola, and the method we use is to determine the x-intercepts of the function, we equate the entire equation to 0. So our equation for the parabola is f of x is equal to minus x squared plus 7x plus 8. Now f of x is equal to 0. It means the whole equation is equal to 0. Then from there, we solve the equation by any method that we are comfortable with. Mine here, after equating to 0, I notice that the leading coefficient is negative, so I can make it positive by dividing the equation by -1. Now, we can solve this equation using quadratic formula, completion of the square, or factorization. So in this case, this has been solved using factorization to give the two values for x. Why do we need two values? We need two values because our graph is crossing the x-axis at two different points. It's crossing at point A and it's also crossing at point B. Therefore, one x value is for point A and one x value is for point B. We have to decide which one is for A and which one is the B. A is on the negative side of the x-axis. Therefore, the x-coordinate of point A is -1. And B is on the positive side of the x-axis. Therefore, the x-coordinate of point B is 8. And that gives us the coordinates of point A and B. So quickly to reiterate the method to determine the coordinates of the intercepts, the x-intercepts, we replace y with 0 and solve the resulting equation. Now, the same applies to the straight line, g of x. G of x is equal to -x plus 1. To determine the coordinates of D, where the graph is crossing the x-axis, we equate g of x to 0 and solve for x. So the coordinates of D are 1 and 0. Our equation is solved. Now, the x-intercepts of the graph, they are the ones that are used in determining questions like these ones that I've put on the right-hand side here. I want to find the values of x for which f of x multiplied by g of x is less than or equal to 0, and f of x multiplied by g of x is greater than or equal to 0, and also x multiplied by f of x is less than 0. I just picked up 3 questions here as an example. Now, the understanding that we need is that when a graph crosses the x-axis going upwards, the function there is positive. So this whole part here, f of x is positive, both for the straight line and for the parabola. The graph is positive all the way. The graph is positive. Then this side, the parabola is also positive all the way. It is positive. So once a graph crosses the x-axis going upwards, it is positive. Now we need to remember that at the x-intercept, the graph f of x is equal to 0 along the x-axis. Then once it crosses the x-axis going upwards, the top part is positive and the bottom part is negative. This is what we have. Now, if we ask you this question where we say, what are the values of x for which f of x multiplied by g of x is less than 0 or bigger than 0? We need the ideas of integers. In other words, we are saying to you, this product here, f of x multiplied by g of x, if it's less than 0, then it means this is a negative product. It's a negative one. So what can we do to be able to get a negative answer after multiplication? We know that you get a negative answer if you multiply a negative number times a positive number. You get a negative result or a negative answer if you multiply a positive number times a negative number. So your answer for this type of equation comes from the sections on the graph where when one graph is positive, the other one must be negative. And this is done by comparing the graphs from the x-intercepts. I want you to look at the line that I'm drawing here. So if I cut across like this, going down through -1 downwards, this side, which is the left-hand side of my function, I can see that the parabola is positive and the straight line is also positive. Both graphs are positive. Then let's draw a line across the next x-intercept, which is 1. Now consider what is happening within this range from -1 up to +1. From -1 to +1. We notice that G is positive, but F is negative at the bottom here. That is the answer we need for this question. So we can say the value of x is equal to -1 right through up to +1. From -1 up to +1, the graphs have different signs. When one is positive, the other one is negative, such that if you multiply f times g, you will be multiplying a negative and a positive, and that will give you a negative answer. Look at what's happening from 8 going to the right hand side. So this side here, we see that at the bottom here, this is your straight line, which is G. It is negative. Up here you have the graph of F. It is also positive. So this is positive. This is positive F. And at the bottom here, this is negative G. If you multiply positive F times negative G, the answer definitely will be a negative answer. That is also part of the answer that we need here. So this one starts from 8 and it goes up to positive infinity. So your answer will be from 8 up to positive infinity. Within that range, the graphs have different signs. Look at number 1.2.2. We have changed the signs now. F of x multiplied by g of x is greater than 0. If it's greater than 0, it means it is a positive answer. Anything bigger than 0 is positive. Now, positive results from multiplication happens if you multiply a positive and another positive. It also happens if you multiply a negative and another negative. So what does that mean for us when answering a question like this one? We must find sections on the graph where the graphs are both positive or they are both negative. We must find sections on the graph where the graphs are both positive or they are both negative. And if you look, it is happening on our grid from negative infinity, if you check on the left, up to negative 1. From negative infinity up to negative 1. Both graphs are positive. That is our answer. We also have the same situation if you check from 1 to 8. Between 1 and 8, both graphs are they are both negative. From 1 to 8, the graphs are both negative. Therefore, if you multiply f and g, the answer will be a positive result. Let's look at the last question. I want to find the values of x for which f of x times x is less than 0. Now, if we say x, just x, not f of x, we are referring to the x-axis. The values along the x-axis, and we know that the values along the x-axis, they are positive from 0 to the right-hand side. Then they are negative from 0 going to the left-hand side. That is what we know about the values along the x-axis. Now, we want to multiply x multiplied by f of x to get a negative answer. In this case, we are referring to the x-axis and the function, the graph of f only. So ignore the graph of g for a moment and look at the graph of f and the x-axis. You are going to notice that if you look at the grid, remember, for an answer to be negative after multiplication, you must multiply a negative and a positive. So we are looking for somewhere on the grid where when the x-axis is negative, the graph f must be positive. And we can see that this is happening from x is equal to negative infinity up to x is equal to negative 1. If you look from negative infinity up to negative 1, we have that situation where the x-axis this side is negative, but the function f is positive. This is my graph f is positive. So if I multiply a negative x this side multiplied by a positive f, the answer will definitely be a negative answer. Let's also carry on. If you look at point 0, 0 is here. From point 0, moving with the graph going to the right hand side until we reach point 8. From 0 up to 8. Between 0 and 8, the x-axis here is positive, but the graph of f is negative. So once again, if I multiply a positive x and a negative f, my answer will be a negative answer. So that means my answer for this question carries on to say also from 1 up to 8. From 1 to 8, the two have different signs. That is f of x multiplied by x is less than 0. For interest's sake, we may want to look at what's going on from 8 to infinity. So that means this whole side here, you will see that this one is a positive x and this one is a positive f. So if you multiply a positive x and a positive f, the answer will be a positive number. In this case, we want a section or sections where the signs are not the same. That answers this question. So to summarize quickly, we have explained how to find the x-intercepts. We equate the equation to 0 and solve for x. Then I have put these questions: f of x multiplied by g of x is less than or bigger than 0, because the answers to these questions are determined also by the x-intercepts. If f of x multiplied by g of x is less than 0, you must find some way where the signs are not the same. For this one, you need the graphs to have different signs. Then if your value is bigger than 0, then you must have exactly the same signs. Then your question is answered. We expect this in grade 11 and in grade 12 functions. In this particular section, we have explained how to find the coordinates of the points where the graph is crossing the x-axis. In other words, the x-intercepts. The method is the x-intercepts are found by substituting x with 0, then y with 0. To find the x-intercept, f of x must equal to 0. To find the y-intercept, x must equal to 0. And we explained that the x-intercepts are then used for answering these questions where f of x times g of x may be bigger than or smaller than 0. All right, thank you very much, ladies and gentlemen. I appreciate your support. Thank you for subscribing and for encouraging your friends and brothers and sisters to do the same thing. Let's meet again when we discuss more mathematics concepts that are tested in our examinations, grade 11 and grade 12. Thank you.